Good morning, students. Let us study today S block elements. The elements in which last electron enters the outermost s orbital are known as S block elements. As s orbital can accommodate only two electrons, two groups belong to the s orbital of the periodic table. Elements of group 1 are lithium, sodium, potassium, rubidium, cesium, and francium, collectively known as alkali metals, because they form hydroxides with water which are strongly alkaline in nature. Now group 2 elements, these includes beryllium, magnesium, calcium, strontium, barium and radium, are commonly known as alkaline earth metals because their oxides are found in earth crust. Now look at the S block elements. This is the position of S block elements in periodic table. Group 1 and group 2 are known as S block elements. Right now you have studied. And these are given with the atomic number, like atomic number of lithium is 3 and 2 electrons present in s orbital, and that is 2s. In sodium, 2 electrons present in 3s orbital. In potassium, it is 4s, so on and so forth, as you can see in the whole first group, which are known as alkali metals. Same here, you will find the atomic numbers of alkaline earth metals are also given. Now look at the electronic configuration of group 1 alkali metals. Electronic configuration of lithium is 1s2 2s1. It means one electron present in the outermost 2s orbital. In case of sodium, one only electron which is present in 3s orbital. In potassium, it is in 4s1. In rubidium, it is present as 5s1. In cesium, 4s2, and then it will come 6s1. The last one is, as you can see here. And the last francium you are seeing, it is present in 7s1. Now let us study the properties of these alkali metals. First one is ionization enthalpy. It is the minimum amount of energy required to take out an electron of the valence shell from an isolated gaseous atom. Ionization enthalpy of alkali metals are low and decreases down the group from lithium to cesium. It is due to increase in atomic size and shielding effect, which outweighs the increasing nuclear charge. Here the ionization enthalpy you can see on the screen in kilojoule mole inverse. Ionization enthalpy of lithium is 520 kilojoule mole inverse. Sodium 496, potassium 419 kilojoule mole inverse, and you can see for rubidium, cesium and francium, ionization enthalpy decreases gradually. It means the reactivity from lithium to cesium increases. Next is hydration enthalpy. The hydration enthalpies of alkali metal ions decreases down the group with increase in ionic size. Here the order is given: lithium ion, which is the smallest in size, and the size of other metal ion increases gradually. Here we can say that the size of Cs positive cesium cation is greater than other alkali metal cations. Hydration enthalpy of lithium ion is minus 506 kilojoule mole inverse. It is maximum. Here the meaning of negative sign is the process is exothermic in nature. Next, let us study chemical properties of alkali metals. The alkali metals are highly reactive due to their large size and low ionization enthalpy. The reactivity of these metals increases down the group. First, we will see reactivity towards air. The alkali metal tarnish in dry air due to the formation of their oxides. Some examples you can see, students, on your screen. This is lithium solid. When reacts with oxygen gas forms lithium oxide. Its formula is Li2O. This is normal oxide where oxygen exists in its normal oxidation state, -2. Next example is the formation of peroxide of alkali metals, where sodium metal forms with oxygen and its formula is Na2O2. Here oxidation state of oxygen is -1. Next one is superoxide. Formation of superoxide takes place only by potassium, rubidium and cesium since they are large in size. Formula of superoxide is MO2, where oxidation state of oxygen is only -1/2. Next you can see reactivity towards water. Alkali metals react with water to form hydroxide and dihydrogen. You can see in the reaction metal capital M represents all alkali metals. When dissolves or reacts with water, it produces metal cation and OH negative. If you will combine these two ions, it will become alkali, that is water soluble base. Along this, it releases hydrogen gas. They also react with proton donors such as alcohol, gaseous ammonia and alkynes. It liberates during the reaction dihydrogen, as you have seen reaction in water. Next is reactivity towards dihydrogen. The alkali metals react with dihydrogen about 673 Kelvin to form hydrides. The alkali metal hydrides are ionic solids with high melting points. See the reaction where metal capital M is representing all alkali metal, when combines or reacts with dihydrogen forms MH. This is metal hydride. It is salt-like hydride or ionic hydride. Two ions are present in this hydride, as you can see here, are M positive and H negative. Since this hydride comprises of ions, that's why melting point of this hydride is very high. Next reactivity we are seeing towards halogens. Alkali metals are readily react with halogens to form ionic halide. See the reaction alkali metal capital M when combines with halogen produces MX. Here X is the symbol for halogen. However, lithium halides are somewhat covalent in nature. And next property here only you can see is reducing nature. Alkali metals are strong reducing agents, where lithium is most powerful reducing agent with E0 value, that is equals to -3.05 volt. This E0 value -3.05 volt represents that lithium is a very powerful reducing agent amongst all alkali metals. Thank you, children.